In this video, I will show how to build a digital thermometer based on an Arduino Uno that uses a KTY81 Silicon PTC positive temperature coefficient sensor to measure ambient temperature and display it on an I2C OLED screen. Here's a breakdown of how the circuit works. 1. Sensing circuit voltage divider. At the core of the measurement system is a simple voltage divider. It consists of a fixed 1 kilo ohm resistor paired with the KTY81 sensor. Principle of operation: the KTY81 is a positive temperature coefficient PTC sensor, meaning its resistance rises as the ambient temperature increases. Signal behavior: resistor R1 is tied to the 3.3 volt supply, while the KTY81 is connected to ground. The junction between them feeds into the Arduino's analog input pin A0. As temperature climbs, the sensor's resistance grows, which in turn raises the voltage at A0. This varying voltage becomes the measurable signal that reflects temperature changes. High precision reference AREF. A distinctive feature of the circuit is the connection between the Arduino's AREF pin and the 3.3 volt rail. Standard versus custom reference. By default, Arduinos use the 5 volt rail as the analog reference, but this can introduce noise into measurements. Improved accuracy. In this design, the stable 3.3 volt regulator is used as external reference. This provides a cleaner, more consistent baseline for the ADC, allowing the Arduino to measure the sensor voltage with higher precision. Result: the temperature readings become steady and reliable, eliminating the jumpiness often seen when relying on the noisier 5 volt rail. 3. Data processing Arduino Uno. The Arduino Uno handles 3 essential tasks in this thermometer design. A. Analog to digital conversion. The analog voltage present at pin A0 is sampled by the Arduino's tender ADC, producing a digital value in the range of 0 to 1023. B. Resistance calculation. Using Ohm's law within the program, the Arduino computes the actual resistance of the KTY81 sensor based on the measured voltage. C. Linear translation to temperature. The calculated resistance is then mapped to Celsius. Since the KTY81 has a nominal resistance of 1000 ohms at 25 degrees Celsius, the code applies this reference point as an offset to determine the current ambient temperature. 4. Output OLED display. Processed temperature data is transmitted via the I2C bus using pins A4, SDA, and A5 to the SSD1306 OLED module. Header display. The screen begins by showing the word temperature as a clear label. Large reading. Large, easy-to-read digits present the current measurement, example on 27 degrees Celsius, prominent in the center of the display for maximum visibility. User experience. This layout ensures that the information is both accessible and visually appealing, making it simple to monitor ambient temperature at a glance. Closing note. That wraps up the build. Thanks for watching, and see you in the next project.